So the first thing I'm going to do here is describe the data. It's a contrived example, so I'm somewhat making these up, these values, but I'm going to try and refer back to at least data structures and examples that I've seen before. So let's say I have documents, and I know that they're going to be approximately 10K in size on average. Excellent. I'm going to have 6 million of them, and I know that in each one there's a globally unique identifier, GUID. And this is what I'm going to use for my shard key. So I've got 6 million of them. I've got a known domain. A GUID is a sort of a well-defined thing. And in our case, what we're going to define the GUID as is a 32 character hex string. And I'll show you what one of those looks like in just a second. So our GUID is going to be a 32 character hex string. There's going to be 6 million of them, and the associated data in this document brings it up to an average document size of 10K. So if we multiply that out really quickly, we'll note that we have, not counting indexes, just purely the data themselves or anything we're going to add on to there later, we're going to have approximately 60 gigs of data here. So knowing this about the data, how many chunks are we going to need to split this into so that it's reasonably well distributed? It's not going to require to be split as we insert a lot of data. We know that our default max chunk size is 64 megs. So we could divide 64 megs into 60 gigs and get a chunk count. But if we do that, a lot of those chunks are going to be quite close to the maximum. So there's going to need to be splits as soon as we start adding data to the ranges. So probably don't want to fill them up to 100%. So let's use a different value. Let's use half of the max chunk size. So our value is going to be 32 megs. So we're going to try and fill each chunk to about 32 megs. Okay, so you can afford to be pretty approximate here. You don't need to be exact. Now, our GUID is this 32 character hex string. So what does that look like? Well, just to illustrate it, I've kind of hacked together a very basic way of getting us a GUID-like construct in the JavaScript shell. So this is a function called GUID that I've just put together. And it constructs the strings 4 characters at a time, just to make sure that things are nice and random and don't get a lot of zeros or various other things in here. So it's very much a hack. It's not an elegant way of doing things, but this is just an example. So let's just run that really quickly. So you can see there's 8 of them here. That gives us this 32 character string. And each one of these will have 16 permutations, right? Because it's hexadecimal. So it's 0 to 9, A through F. So this is what our GUID is going to look like. So to go back to our little calculations we were doing, first of all, we divide 32 megs into 60 gigabytes. Forgot to do that step. So 32 megs into 60 gigs gives you approximately 1,920 chunks. So that's the minimum you're going to need to get approximately 32 meg sized chunks out of 60 gigs worth of data. So just divide this into this, you get 1,920 chunks. So that's the target we're going to aim for. And if we looked at the GUID, we know that it's a 32 character hex string, so that means there's 16 permutations. So how many of these are we going to need to actually get to 1,920? Well, 16 by 16 is not going to get us there, unfortunately, because 16 by 16 is only 256. But if we add in another digit in here, 16 to the power 3 basically, so this is 16 to the power 3. That gives us a value of 4,096. That's far in excess of our 1,920. So what we could just do is divide that by 2. Divide it by 2, and that equals 2,048. So we know that we're going to need to iterate through at least 3 of the digits in this GUID to get us our nice splitting factor that we require. We don't need to quite go through every permutation of those 3 digits. We can go through roughly half. So how do you go about doing that?